In this example, we will explain about application of stack to check the validity of an expression in terms of parentheses or brackets. The stack structure and the functions described in the previous examples used here also. In addition, the following functions are also used. The function is open. It takes a character type of variable as an argument. If its value is either opening parenthesis or opening square brackets or opening curly braces, it returns 1, otherwise it returns 0. Similarly, is close function takes a character as an argument, and if that is happens to be either closing parenthesis or closing square brackets, closing curly braces, then it returns 1, otherwise it returns 0. This function takes two character type of arguments and returns 1 if the first character is opening type of brackets, any type of bracket, either it is a opening parenthesis or square bracket or opening curly braces, and the second argument B is respect to matching closing parenthesis, then it returns 1, otherwise it returns 0. These are the extra functions we propose to use in the following main program to check the validity of an expression in terms of brackets. The main theme behind this main program is as follows. We will take a string or expression. We will traverse character by character. Whenever we encounter a opening type of bracket, that is, it can be square bracket or curly braces or simple parenthesis, then simply it will be pushed into the stack. Whenever we encounter a closing type of bracket, that can be closing type of square brackets or curly braces or normal simple closing brackets, then we'll pop the character, the bracket which is in the stack, and check using the function match whether they are same or matching type or not. That is, we know that most recently opened bracket is the one supposed to get closed first. By chance, most recently opened bracket is a square bracket that is in the stack now, and we have encountered a closing curly braces, then the expression is invalid expression. So like that, with the help of the match function, we decide whether the expression is valid or not. Whenever we found that the closing brackets which we encountered now and the one which is on the top of the stack, if they are not of matching type, then we can outrightly say that the expression is invalid expression. We need not require to traverse the expression any longer. We can outrightly say, we can print a message invalid and come out from the program. Like this, we'll traverse the given expression character by character, and whenever we encounter a opening type of bracket, that we'll check up with the help of isOpen function. We simply push the opening brackets into stack, and whenever we get a closing bracket, we simply pop the topmost bracket from the stack and try to check whether they are matching type or not. If they are not matching type, we can outrightly say that the expression is invalid. Like this we proceed till we encounter the null in the string. After completing the expression traversal, if we happen to find some brackets are left over in the stack, that is, they are the brackets or parenthesis which are open but not yet closed, which mean that expression is invalid. Otherwise, that is, if the stack is empty, then all the brackets which are open, they are closed, which means that expression is a valid expression. So this is the background behind this concept, this problem. So we will be using next slides how it is going to work. In the main program, we have used a stack type of variable A and stack type of pointer variable P. For ease of convenience, we have taken a string, and that is expression directly assigned to a string variable X. And then the address of the stack variable A is assigned to P. And then stack is initialized by calling the init stack function. Now the given string X is traversed character by character with the help of the for loop. Whenever we encounter a opening type of bracket, simply we are pushing that one into the stack by calling the push function. Similarly, whenever we encounter a closing bracket, so we call match function. We'll pop a character from the stack and compare with the X of I. And if we find that there is no match, we can print a message invalid and come out. Like this, the for loop is used to traverse the given expression character by character till we encounter null. Once we come out from the for loop, isEmpty function is called, and if it is identified to be empty, that is stack is identified to be empty, which means that all the brackets which are open, they got closed, then we will print that expression is valid. Otherwise, we say that expression is invalid. So these are the things main program does. Now we have encountered a opening parenthesis. Thus, the function push is called and this will be asked to push into the stack. Thus, top value will be now stack's top value is made. Then the opening parenthesis is pushed into the stack. Now we have encountered a opening square bracket. Thus, the same will be pushed into the stack. Now we have encountered a closing square brackets. Now we pop out the topmost character, that is opening square bracket is popped out. And these two things are compared whether they are matching type or not by calling the function match. They are matching. Thus, the for loop is going to continue further. This time we have encountered opening curly braces. Thus, the same will be pushed into the stack. Now we have encountered a closing curly braces. And then we pop the topmost character from the stack, that is, we get opening curly braces. Then when we call the function match, it returns 1. Rather, they are matching type. Thus, the for loop is going to get continued. That is, expression is valid till now. Now we have encountered a closing parenthesis. Then when we pop the topmost character from the stack, that is the opening parenthesis, and when we match, both of them are same type. Thus, expression is valid till this point. We have reached the end of the expression, and when we compare whether the stack is empty or not, we find that stack is empty, which means that the expression is valid expression. Like this, with the help of stacks, we can check whether the expression is valid or not.